Hello, everyone. Welcome to this week's Bounty episode of the Day Zero podcast. I'm Spectre, with me is Z. This is our last Bounty podcast for this year, and tomorrow will be our last binary podcast for this year until we return on January 10th and 11th. So just wanted to give that as a heads up. With that said, let's jump into our topics for this week. So we'll start off with the headliner, the bug that everyone's heard about at this point, and the bug that will plague server admins for years to come. This was a vulnerability that was disclosed, and a POC was released on a bug in Apache's Log4j2, which is used by many things, evidently. Just to give you an idea of the broad range of things that use this, Ghidra was affected. Which, I mean, if Ghidra's getting affected, that's pretty insane. It also affected Minecraft, which was the initial big targeted focus, and it's also used a lot in Enterprise, which is obviously the more critical aspect to it. Is the
Sorry,
fact that it's
why was Minecraft the big target of focus?
so Minecraft was where it initially surfaced when a lot of
Oh,
the
okay.
initial
I didn't
reports
know
came
that.
through. Yeah, so there were people that were going in Minecraft servers and just putting the jndi string into the chat, and it would target, I believe, both servers and anybody connected to the server.
Yeah, I saw some
So
pictures of that. I just assumed that was where some people went afterwards because, of course, Minecraft is a popular service to run.
yeah, I don't know why, but yeah, Minecraft seemed to be the big target that everyone was talking about when it first started blowing up. So yeah, it was kind of funny, but obviously, it affects a lot more than Minecraft. It affects anything that's using, well, most things that are using Log4j anyway. I guess we'll get into a bit of the nuances in a second here. It was disclosed by a researcher working for Alibaba, and the issue, well, it's kind of dead simple. Log4j would perform lookups on any strings that are going through their logging, and those lookups could be abused to use the LDAP protocol to fetch a remote Java class and get RCE. Basically, it's like a format string bug for Java,
So,
and it affects everything that uses Log4j and logging.
yeah, so you specifically call out LDAP, so this is like more traditional, you would consider this just like a JNDI injection. Because I mean, JNDI supports a lot more than. In this case, you're also able to inject the fact that it should use JNDI. But a JNDI injection, you can use like LDAP is one example, Cobra, RMI, I mean DNS request. It just looks up what is it? Java naming and directory interface, I think, something like that. So like you can pass it over to any sort of remote or not remote lookup service of that sort, such as LDAP. So LDAP was the easy target to hit, the common one, largely because on older versions of Java, you could basically use LDAP for remote code execution. Just trivially, basically send it a class back. And it's like, okay, let's use this class. On newer versions, you would have to look at using kind of going more of a deserialization approach. You can still get RCE. You can, maybe get I think Bean Factory has been looked at. Actually, I do have a link for talking about JNDI injection in general, which does talk about doing exploits on more modern things or on more recent versions of Java. I believe, yeah, they use the Apache naming factory, Bean Factory, as an example, which is in Tomcat. Uh, well, Apache naming is much wider used than that, but was being used in Tomcat. It kind of goes more with the deserialization feel when you have to exploit it that way. Like LDAP is just very easy to exploit, but this is still exploitable on every version of Java. I saw some discussion regarding like, oh, it's only kind of older Java runtimes that are vulnerable because newer ones won't load remote classes by default. But you just have to use a different targeting method, basically.
Yeah, it's one of those things where the exploit strategy that's immediately available is mitigated, but there's other ways to do it.
Well, at that, like it's not even entirely mitigated either. Because you can still get like environment variables in that initial LDAP like callout, it's
Yeah.
still going to, expand any variables that you're including and send them off. So you use that in the host name, and you see the lookup, you see the first hit on LDAP, something's going on there. So like you can still leak plenty of sensitive information out of environment variables. Oftentimes there will be secrets in environment variables. Not always, but it's not uncommon either. So you've got that
Especially
as
in
an
like an
option.
enterprise environment. So
Yeah, and
yeah.
because this is variable expansions, you're kind of left with like it's very difficult to patch this out at like the WAF level, just setting up some rules or something. Because I mean, there are so many ways that you can get the same letter rendered and just work its way into the final expansion. It doesn't have to be jndi. You can have another variable inside of the variable that you're trying to expand, and just all the layers of indirection. It's very hard to actually patch this one at that level. Main mitigation, either if you don't want to just update, is deleting the jndi lookup class itself so it can't be used at all.
Yeah.
um Go ahead.
Yeah, so I was just gonna say, the main like thing here is the fact that people can get these lookups pretty easily into like any logging, and by by being able to abuse the jndi injection, as you called it, um, there's various things you can do. Like we were talking about earlier, you can get RCE through LDAP with a remote class, but you could also leak and exfiltrate environment variables, which was another attack I saw people doing on Minecraft. I will quickly mention from chat as well. I8BR linked a tweet, which I thought was pretty funny. I just checked it out while you were talking, and somebody used it to get Doom running inside of Minecraft. So it's always fun to see Doom. I don't know if I've
Does
really
it
seen that
run
before,
Doom?
but
Yeah.
yeah, does it run Doom? The classic meme. So thought I'd bring that up. But yeah, I mean, so when this initially came out, I'm not gonna lie, I was really skeptical. I was talking with some people about it, and we thought it was one of those things where people were trying to blow it out of proportion, and they were just kind of taking it and running with it. Because when we looked at the source code for Log4j, um, this all works via lookups, right? But the default configuration has no lookup set to on, which means that these lookups by default shouldn't be getting performed. They shouldn't be getting parsed out of the logging strings and like be able to be abused this way. So and that's been that way since like 4 years ago. The commit was 4 years ago that made that change. So it seemed to me like, okay, this could hit certain setups, but by default, this should be fine. So I was skeptical about it. But then obviously, more and more started coming out about it. More and more targets or products seem to be affected, and I was just left kind of confused. I was like, why are so many things seeming to be vulnerable to something that is, for lack of a better term, secure by default? Because that's always been something that we've hammered on the show on past things we've talked about is like secure defaults can do a lot of good in preventing a widespread attack like this from happening. But in this case, it didn't really do anything. Um,
Yeah,
so,
and
and
there's
you have kind of a theory on that, so I'll let you elaborate.
there's probably two main reasons behind that. One, turning it off. So this is the like format no lookup, I think was the configuration. It's one of the mitigations that you can implement. One of the things there is just the fact that turns off like all variable expansion in your log messages. So if you are a corporation that say includes a server name in an environment variable, now you have to do that lookup manually in your code to get that and just inject it as part of the string rather than just doing like a $sign expansion on it. I could see it being one of those features that is just turned on by a lot of people. And then the other half of this is in Java, updating is not. I'm The whole update ecosystem is kind of slow. I mean, I think I think Log4j has, maybe had like one or two updates in the past year. Um, I might be mistaken about that. I'm purely going off memory. I wasn't expecting to need exactly that information. but like it's not that common. So, a little bit bad timing, another Java application maybe only updating once a year, bad timing, it becomes like 2 years, if even assuming they stay on top of like getting absolutely every dependency updated. But then that comes down to all the dependency management. Maybe something else needs, like, we need this version to be less than this, or they didn't update their dependency, so then your dependency manager goes and says, well, this version's compatible with everybody, so we'll use that, thus using an older version. So I think it's part of just a slower development cycle, slower releases, dependency management, and kind of some issues like that kind of just lead to, also, I'm sure, plenty of old stuff out there. And of course, just it's running. Why update it? Why take it down to update? Just, it's been running for years. Who Don't worry about it. Um, there's, I think, that aspect too. Or I mean, is when you're looking through for things to update, you might be looking for what has security fixes to update. And so not really hitting Log4j, which up until recently I don't think had a lot of like big security patches going on, just general like feature patches. Well, you don't need any of those. So I feel like those are kind of the two main factors at play in that. Can't confirm that, but that would be my hunch.
Yeah. It was a little hard to dig into because like we were looking around in the Log4j like repository and stuff, and then I just remembered how much I hated looking at Java, and you know, just I remember there was a reason that it's been years since I've really looked at Java code because it was not fun to follow. So I tried to dig into the nuances a little bit more, but didn't really get too far in that. Um, but yeah, I mean the main thing is here it does affect a lot of devices regardless of what the default is. So like I said earlier, this is going to be something that's probably going to have an impact that's felt for years. This is
Oh yeah,
something that's going to be tested against web servers and whatnot forever. So
and it's going to be like hard to spot everything using it. Like, I mean, this isn't just the case of, well, my front-facing web apps are using Log4j, therefore I'm safe. This is one of those things where there can be a lot of really random software just sitting around that happens to be written in Java, and Log4j is one of the most popular logging libraries in Java. Like, I
and it's
came
been around
across it
forever.
a ton. Yeah, and I guess on the note of it being forever, the 1.0 version is not vulnerable to this. It does have some lookups, but it doesn't do this style of lookup. So that also means S log4j or something like that. Oh no, I think it's just the S in front of it. I don't know what it stands for, but that one being more of a fork of the 1.0 also isn't vulnerable. I think they actually went and updated their site to make it clear that they're not Log4j based anymore. Kind of distancing themselves from, or trying to distance themselves from all of this. One thing you mentioned kind of early on was relating this to kind of a format string vulnerability. And I saw kind of a discussion on Hacker News around this. Where they kind of related it as this first case being okay, where you just, log debug and it's expanding the variables in the format, but not in the actual message data itself. So if you did user agent and just string concatenation to add the user agent, then you can do the log injection. I do want to be clear that that is not the case with this vulnerability. One of the issues, actually, we haven't really talked too much about this, about this aspect yet, is you would expect, variables in kind of this first part of the log kind of being okay. Like, you're providing a format for the following message, and then the variables themselves would be the part that, is generally untrusted, should just be parsed in accordance with whatever's being looked up. And that seemed to be what Log4j's documentation indicated also. It's always about, variable expansion in the format. Even that configuration option we talked about, it was like format no lookup, or no lookup format or something. Like, it was indicating that this was for those format messages that part of the call would not do any lookups. But what Log4j was doing is they were performing the expansions both on the format, but also on all of the user data provided into it. Because I could kind of see less, or I can see more of an argument if it was just format and then it's kind of relayed to the format string vulnerability at a conceptual level. When you go that second case, you just kind of append everything into your string and print it out, and then it's interpreting the format. But in this case, it was kind of going against everything, which was a very surprising thing for Log4j to be doing. Yeah, I mean, it's interpreting what would generally be considered untrusted data and very surprising. Um, so I mean, with
Yes,
that,
I was a bit confused about that initially too. Because that was our thinking too, like just the initial like format, like that seems to be kind of an ask, right? If you have to get data in the first like format type string, and it's going to be doing logging, like even if you can get user data in there, uh, the part of the reason I was initially skeptical was like it's not generally it's not going to be easy to get it into the first string. So that was like really weird too. That's good that you brought that up because I kind of forgot that aspect um, in the last like day or two. But yeah,
yeah, and I
it's
mean,
very relevant.
it was, I had the same thought initially. Was I had seen some of the thoughts on, well, it's just in that format string that is a bit higher of an ask, not necessarily the largest ask though, but um it's more of an ask at least. But yeah, no, the fact that it's running is, I think, the most surprising aspect. The fact that it's running that lookup over everything that comes into it is just a little bit crazy to me.
Yeah, it's the way this is architected is a little bit insane. It's um, and as such, it's not really surprising that there's been POCs for this bug going back for months. I don't have the link handy on me at the moment, unfortunately. Maybe I can grab a link and we'll put it in the blog post or something as a reference. But um, there was a GitHub repo that was discovered that had a POC for this vulnerability like 8 months ago, I think. So it is a little scary to think about how long this could have been being abused that it just wasn't like known about or public. Um, and I have kind of a joke along that line too, because earlier on I mentioned that this bug affected Ghidra in searching in Ghidra, and Ghidra was one of the first things that shipped a patch for this bug. Um, they had a new release out same day. It did more than just fix Log4j. It seemed like a release that they already had kind of prepped and ready to go. That they tagged the Log4j patch on top of. Um, but it's kind of funny because I made a statement saying like it's kind of weird that Ghidra was one of the first things to patch this issue, and someone else said, "Well, yeah, of course they've had this patch ready for years." I thought that was kind of a funny thing that I'd relay, but
I mean, I wouldn't be that surprised by it.
I wouldn't either.
So
That's what makes it a good joke.
yeah, this is one of those issues that, like, if you're aware of the lookups, like, it's one of those things that you can kind of accidentally have come across. If you're testing for this sort of issue, like if you're aware of just like jndi injection on a whole, like if you're remembering that and actually testing for it, you may be able to come across this somewhat accidentally, and then it takes a while to kind of root cause. Well, where the heck did this come from? I don't think people are immediately going to be thinking, I'm assuming, you get like a callback. I'm assuming you're not immediately going to think, oh, the logging library. So it would take a little bit to figure that out. But once you got there, obviously you realize the impact of this. I wouldn't be that surprised because there aren't like big conditions to have found this.
Yeah. So, yeah, I mean, just to summarize, I mean, it seems the impact here is just so large, and it's able to hit so many targets because, uh, one, it's a useful feature that people seem to like, and make a lot of use of, and two, because dependency hell is just really shocking to people I guess, how many things are using Log4j eventually in the stack. So yeah, I mean, like I said, the ripples will be felt for a while, and it has that unfortunate combination of being both really uh, impactful and also really easy to exploit. There's not really any super hard conditions that you have to meet or anything. So yeah, I did see a lot of. I loved a lot of the memes that came out of this. I made a tweet about this. There's been a lot of great memes that have come out. There has been a bit of a discussion about Java, like as a language, because as soon as this came out, of course, you had to guess that there's going to be a lot of people coming out, kind of shitting on Java, um, saying that 3 billion devices run Java, and this is why they shouldn't. Going along with those kinds of jokes. There were some people saying like this isn't really Java's fault, um, and this is like a Log4j issue. And there were some interesting discussions that came out of that. Um, I mean, Java's been criticized over the years for a lot of different reasons, so I think people are just they like to meme on it. It's kind of like the Nickelback of languages. Whenever something bad happens and it's somewhat tangentially related to Java, people do like to jump at it.
It's a fair way to put it. I mean, in this case, so I haven't seen those discussions that you're referring to. So I haven't really seen the arguments on both sides here, but my look at this is entirely unrelated to the Java as a language. It's not that Java as a language just makes it really easy to um do these lookups or something. Like I could actually understand that if it was like a language feature where you see like in Python doing the variable expansions and then there was an RCE there. Um that's somewhere that okay, you can put some blame on the language. I don't think Java leans itself towards being able to do this. This is absolutely something that they added on top of existing Java strings, I guess here. I did see an IAPR just remind me of this in chat, but about kind of paying open source development. It said P512 also mentions I do think it's a language thing, but no popular language would solve this. How do you see it as a language thing?
So
Okay,
maybe I
so
could chime in a little bit here, just by saying like I agree. I think the blame here primarily falls on like Apache and Log4j. Um, I could kind of see the argument of going after Java for like jndi, because jndi is like a stupid powerful um, and a bit of a mess of a subsystem, and that's kind of like I guess the vector that's being used here. But yeah, the issue is more on Log4j here ultimately.
yeah, but I mean, JNDI is just like an API effectively. Um, just to access things that people genuinely access plenty. Cobra isn't that unheard of. LDAP obviously isn't that unheard of either. It said P512 did I'll say if we had taint analysis built into the language, that would probably help. I've never heard that one, honestly. Having the taint analysis built into the language. I'm not sure though if that would have actually helped here. If it were the case, we were talking earlier about the whole format string versus the data and the fact that Log4j was processing for variables in the data and in the formatting string. I think if this were just in the formatting string, then yeah, taint analysis could pull it out and be like, hey, this is getting tainted by user data, and you probably shouldn't do that because you shouldn't like users taint the formatting string for sure. In this case though, because it's in the data, like it's I feel like Log4j was kind of the mistaken aspect here of the fact they were even processing all the data piece, all the variables being passed in. I mean, jndi, I guess it does also feel fairly Java-esque. And that's something IAPR just mentioned also. Um, that one does in particular. Like it does feel, but it doesn't feel like this is a language issue itself to me. I don't know. I mean, this probably would take I'd want to look at a few more of the arguments, see what people are actually saying about this. I haven't really done that, and root them all. We should remove string concat and only use format string. I mean, that wouldn't have saved us in this case, so no.
Yeah, yeah. So
But
that's the important thing with like the taint analysis thing is it seems like Log4j was mistakenly treating all data going to logging as trusted data. Um, there wasn't really this idea of untrusted data. They did the lookups on everything. So
and
yeah,
just to be clear, since I did mention when Rudimal said we should remove string concat, that was a sarcastic comment. /s all there for anybody listening who can't actually see that. I don't want to misrepresent them.
yeah. Um, one of the other points that I wanted to bring up before we move on to is like this is one of those times where centralized security has or centralization has kind of come back to bite people, um, because you know the main reason that everything is vulnerable here, it's not so much because of Java, like we've said, this isn't a bug in the language, but it's more just that so many things use Log4j, right? And the reason I mention that is we talk about centralization generally in a positive light on the podcast, centralizing security, centralizing patches to like one product or whatever. But the obvious issue you run into is when something like this is found in such a critical piece of software that's used by everything, well, then everything's going to be vulnerable to it. So, yeah, I did want to bring that up since it's a point that we hit on, but
Yeah, it
yeah,
is. It's a
it's an
fair
unfortunate
point.
consequence.
I mean, it's the consequence of the whole idea of centralizing security. Um, it's kind of the trade-off. By centralizing it, you can also fix this in one place. You update, this is fixed on like everything. Then
Yeah,
I
it's too bad
do.
that Java's updating system is less than ideal here.
Yeah,
So,
I mean,
it doesn't
there
help
are
very
other
much.
issues, but I mean, centralizing things is generally a trade-off because when you do have a vulnerability in something that's centralized, it's going to be much larger than if you were doing all your security ad hoc and then you kind of lead with uh sorry, if you're doing your security kind of ad hoc, then you end up with those little one-off sort of vulnerabilities, just this little tiny thing in this one little area that still has an impact, but it's nowhere near as large. Whereas centralizing, one thing, it's one place breaks everything. I do want to pull it up P512, also mention, like what we see here is flow from untrusted string log message into trusted URL. Fair point. Yeah, that is ultimately once you process the input through the Log4j library itself, um, you would be seeing it going from untrusted back into trusted. So that's actually a good point and a point in your favor. Um, Not that we're really keeping points on this. I mean, I don't really have a response to that. I've never heard the idea of actually having taint analysis built into the language like that. Um, I'm not sure if there are languages that really do that right now. I
It does sound
mean,
interesting, though. I agree.
yeah, no, it's an interest. Like, I like the idea. Nothing really. I wouldn't be surprised if there's something out there that somewhat aware, like you do some annotations on certain inputs, and then everything kind of gets tainted, and it can do that sort of analysis. Doing the analysis cross a library does feel like it may or may not be able to do so. And I only say that because I mean, oftentimes you end up with black box libraries. It might be harder to do so, but if we're talking about this just as a language issue, language could easily design around that. Just by tracking where things flow. I mean, I like the idea. I've never heard of that before, honestly. But if you want to go that route, you could call it a language issue for not having such a feature.
All right, so we spent a while on Log4j here. So I guess we'll move into our next topic, which is a Windows 10 RCE with an exploit in the link. Kind of continuing that idea of easy vulnerabilities to exploit, I guess. So this is an argument injection in MS Office CMD URI handler, which can be used by malicious websites. On IE11 or Edge Legacy, this can be triggered directly in the browser with no user interaction, really, no user confirmation, I should say. Um, on other browsers, it does require a confirmation dialog, and this could also be exploited by malicious desktop apps. The issue there, pretty straightforward issue. Arguments can be injected into the MS Office CMD commands, which, when used by certain apps, can be used to trigger code execution. For example, the GPU launcher argument, which I'm certain we've talked about before multiple times, because it's an Electron thing. By abusing that argument for Microsoft Teams, you can specify an arbitrary path like command or command prompt in the POC and call it. For that one to work, MS Teams does obviously have to be installed. It doesn't have to be running, but it has to be installed. But that's not the only way to exploit this. There are other potential routes that could be used, and that's going to be relevant later when we talk about Microsoft's response to this.
Yeah, and
The post.
in this
Yep, go ahead.
case, it's one of those vulnerabilities. It's simple. We've talked about many of these sorts of things before. It just felt like it had been a little while since I've brought one up, so I figured I'd bring it back with this one, especially because this is something that's available by default on Windows 10 and 11. The default aspect definitely raises the impact of this one.
Yeah. So the post goes into some detail on how they stumbled on this URI handler in the first place when they were doing some iteration and discovered that it was a fairly complex scheme. They then ended up reversing the local bridge and the app bridge, and that's when they stumbled on the Office UWP or Universal Windows program or whatever. It's not really UWP is one of those things where it didn't really seem to take off the way Microsoft wanted it to, but that's beside the point. But yeah, they stumbled onto the Office UWP app, which generates those URIs. And it uses a scheme for its internal API when the UWP app triggered an Office app to be opened. So, yeah, I mean, they went into some detail on how they discovered it, and that gets a bit more technical, I guess, and they talk about some of the reverse engineering. But the issue is ultimately just the idea that you can inject arguments in the URI. Now, as I kind of hinted at earlier, the story did have a bit of drama attached to it. It's talked about a little bit in the TLDR at the top of the post, but it goes into more detail at the end, and I think anyone who's interested in the drama aspect should probably check out the end because there's a lot more nuance there than the TLDR might suggest, at least from what I read. Basically, Microsoft initially dismissed this issue when it was reported by Positive Security. Then Positive Security submitted an appeal, and Microsoft accepted it as a critical RCE, but then they only paid out $5,000 instead of the $50,000 that Microsoft advertises for critical RCEs. And on top of that, this wasn't patched for 5 months, and it failed to actually, the patch did eventually ship, it failed to actually address the underlying root cause, and it's still an issue on Windows 11. Because from what I read, it seems they only patched the exploit strategy here used, which is the GPU launcher argument for Teams, and it seems like they didn't address the actual argument injection. Microsoft said they are preparing another patch for that. To Microsoft's credit, they did give the okay for Positive Security to talk about this issue. They gave them the end quote go ahead to post this write up independently of its rollout. There is also a bit of clarification on the bounty payout part, and that's the fact that earlier you may remember I mentioned this only works without a confirmation dialog on Edge Legacy. Otherwise, there's a prompt for giving permission to the local app bridge on other browsers and whatnot. Well, Edge Legacy was declared end of life the day before this report was submitted. Now, the researchers do contend here, saying um, the fact that this requires a bit of user interaction in the confirmation dialog shouldn't disqualify the issue. But Microsoft disagreed. They granted the general award for this report because, yeah, that they argued that the user confirmation was a bit of a shield, and this couldn't really be abused without that confirmation dialog on any supported or modern browsers because Edge Legacy had gone end of life. It is really unfortunate for the researchers that like the end of life announcement dropped the day before the report. That's just like really unlucky timing. I kind of feel for them there. I do feel that should probably play some factor in the bounty, though. Like it kind of makes sense that Microsoft would push back a little bit on the impact there. Um, that said, I don't fully support Microsoft in this exchange from what I see. For one thing, their patch was really late and insufficient. And Positive Security mentions there was also slow communication where there was like weeks of silence from Microsoft when they were trying to see what was going on with the fix and stuff.
I mean,
Um,
they mentioned that, but I'm looking at the timeline here. It looks like March 10th they disclosed, March 11th closed, appealed same day, and then a week later they reopened the original report and or okay, I guess that's the 20th now because it's all these numbers ending in 7. I missed that. I thought it was only a week later.
yeah. So there was a bit of a like not great communication going on there. And on the bounty aspect, I do think a drop from 50,000 to a payout like 5,000 is a little steep. Especially considering like Edge Legacy wasn't like a year past end of life or something. It was one day. So I mean like if you go into the technicalities, like yes, it was end of life. And I think that should pay a factor. Like maybe they shouldn't have gotten the full 50K.
But I
It
mean,
does feel
it's
like 5K is a little bit is a little bit too harsh, I guess.
not like Edge just like suddenly became end of life, surprising everybody, and nobody had any idea this was about to happen. Generally, with end of life, you go end of support first.
That's true.
And
And yeah,
there's like the whole
Edge
period
Legacy.
of that. I mean, like everybody's knowing it's going to die. I feel like, as a hunter, you kind of need to take that into account also. You're looking for things for the bounty. Um, Jumping back a little bit on the user interaction. I mean, so on one hand, users always tend to go and click yes on everything. Like that is what users do. um,
Unfortunately,
that
yeah.
said, in this case, like you're kind of comparing this with I can create a random website, have a link on it. You do require kind of a link being opened here, or another application. Like there are other ways to kind of get to that point. But like I can also just create a link to any calculator.exe and pop a calc. Oh, like you can do that getting the same prompt. So where does this one become more dangerous than that? Um, and obviously it is because one argument injection, usually with those you're not, or usually with the just having the link, you're not getting argument injection. You're able to launch something, but the user has to accept it. I don't know. I wouldn't see this as unless it were like no prompt 50,000 because I mean 50,000 I believe is more on the max payout. Like I think
Yeah.
that's part of the thing here too, is like payouts aren't always going to be the maximum amount. I don't know, 5,000 feels a bit low, but at the same time, I kind of feel like I don't know, maybe it's just because we've seen so many of these issues. Um it relies on, having teams install, which isn't that big of an ask in fairness. But it's not the same as just having a direct access to, running anything with a one click. I don't know. I can see at least a bit of reasoning for dropping it. I agree, 5K seems a bit low, but I don't really know where I'd put it either, given the fact there is the prompt still. Fact that users have to, click something at some point. I don't know. I'm not exactly on Microsoft's side, especially on the communication side of things, but when it comes to the reward, it's what they decide to pay out, I suppose.
So that's kind of my thought on it as well. I do think 5K is a little low, but at the end of the day, Microsoft is the arbiter of that. They'll price it, what they think it's worth. Um, I still think you can criticize Microsoft here though for like the communication and the fact that the fix taking 5 months just to like disable the GPU launcher strategy without actually fixing the underlying cause, like that is kind of silly, and I think it's fair to call out Microsoft for that. Um, I think
Yeah,
there
for
were
sure.
too many people that were like linking this story and talking about it and bringing out the pitchforks for Microsoft. I mean, Microsoft is just one of those companies where it seems every time there's something that's even moderately negative that comes out about them, the pitchforks are out, people are ready. Um, yeah, I do think people were maybe overblowing Microsoft's response here, like because there were a lot of people actually. It's kind of funny. Um, there were a lot of people on Reddit and whatnot who were linking this post and were saying like, "This is why I'll never submit a bug to Microsoft," or like, "Nobody should ever submit bugs to Microsoft because of stories like this." And I mean, I guess if that's the way you feel, I mean, then don't do it. But I there there has been good instances in the past too of Microsoft responding to issues and having a good back and forth with the researcher.
I feel like there's
This
been a
there,
decline in the past couple years.
yeah, it does
Um,
seem like there's more negative stories coming out about it,
yeah, we're
but
hearing more negative for sure. But sorry, go ahead.
yeah. Well, all I was gonna say there was I feel like a lot of the nuance was lost. Because if you just look at the TLDR and you look at what people were talking about it, it seems like Microsoft was just like, screw these researchers, we're not paying them out the full amount, and we're just gonna, um, well, they initially
Shafting the
rejected it, right?
researchers. Yeah.
But yeah, that was the general sentiment. It was that the researchers were getting shafted. But then when you look at the fact that like Edge Legacy had gone end of life, and Belusip and Chad actually mentioned the EOL announcement was 2020 of August 17th. So okay, yeah, that's a good point to bring up. It was known well in advance that this was going end of life. So yeah, um, when you look at that and factor that in, it makes the Microsoft's response in the way of the bounty and whatnot makes a lot more sense. And I think that is important to bring up. So
Yeah, talking about the fix, jumping on that a little bit, I will kind of mention here, like, the fact they only fix the argument or the one argument, the GPU launch. Like, yeah, there are probably possibly other ways of getting this, of getting something similar, but like that alone is somewhat sufficient too for the root of the issue. So we've had a little bit of a discussion about this before when it was, I think, a macOS Finder issue, where how damaging is the ability to launch an arbitrary but already installed program without arguments. You can pop a calculator that way. Like that works.
not very useful, but you can do it.
But yeah, like there aren't a lot of applications that do anything useful without also having a degree of argument control. So if they were to patch it so you can only launch just a subset of programs and not control arguments there, you're like it's kind of dealing with the most impact. Now, I don't know. I don't like that as an answer. Like as a security professional, that is not my recommended patch. Is we'll just make sure you can't do arguments. To be clear, like that's not the route I'd say because it just feels wrong to recommend such a band-aid. But at the same time, if I'm thinking about it, like I don't see the damage of just being able to open any application as being anywhere near as high as being able to provide arguments to it. With that said, if anybody listening actually has some thoughts on exploiting that, I would love to hear it and, be proven wrong on this point. Because oftentimes when I do see those vulnerabilities, I am thinking, well, I mean, it is just that app. I mean, if somebody can prove me wrong, I absolutely welcome it. I'm not coming down as I'm sure there's somebody creative enough to figure out some way of, getting some damage out of that. Um, it's just not me.
Yeah, it's something that you'd have to spend a lot of time playing with and seeing what you can do. Just put a bunch of time and effort into it. Um, so yeah, it'd be interesting to see if somebody comes up with a way that this could still be abused. Just to clarify, the way I was talking about it made it seem like Microsoft's patch that they shipped was like totally useless, or that's how it might have came across. That isn't what I was trying to go for there. Um, More what I was just trying to say there was that the patch was like incomplete, or it wasn't addressing like the underlying issue. But it is still like it seems to be a fairly mitigating fix. The known way of exploiting it that they did in this blog post wouldn't work, as I understand it, with the way they patched it. So that is worth considering too.
Yeah, and of course, like other programs, like there's more attack surface, so I wouldn't be surprised if there was another way of doing it.
For sure. All right, so we'll move into our next topic here, which is a server-side request forgery in AppSheet. This is from David Nishuda and their research on Google's Vuln Research program. AppSheet is a codeless workflow and automated app manager, so one of the many that we've seen in the last couple episodes, I guess, or the last couple
We've
months, I
covered a
should say.
few, but not. I don't think we've covered really too many in the last couple episodes specifically.
Yeah. Um, the SSRF here is in the webhook functionality in AppSheet, where it was possible to use a webhook to target the metadata service and receive an access token for the AppSheet application. This was reported to Google and fixed by blocking the service endpoints, which could be accessed without a security header. Um, and they blocked the metadata flavor header, which was used for trusted requests. Um, but that initial fix was bypassed because you could still send another header, being the ex Google metadata request header, and you would still be able to get access to those service endpoints. So then finally it was fixed by making it so you couldn't send that header either. Again, not too much technical depth to that issue. It's just abusing the webhook to be able to send requests to like those kind of internal endpoints, I guess,
Yeah,
and
the core
not
issue.
really considering the attack surface there.
Yeah, the core issue wasn't entirely surprising. They did get a 6,000 and something bounty out of it because it's Google. It was the whole 337, so weird number out of it. But because they got two bounties. That said, they did touch on one topic that I actually thought might be a little bit fun to or at least comment on, and that is, and this actually didn't end up being necessary for them, but they included it anyhow, was that they thought that they had to make a GET request to the metadata service, but the only options for this webhook were that it would send a post, it would send a patch, or I think a delete was the other option. So you can only make those sorts of requests with it, and not just a direct get. So you end up talking about the redirection aspect of using a. Um, I'm assuming he would have used. I'm not sure which redirect he actually used now. I think he mentions it somewhere there. Used one of them, and I just want to kind of call out that concept because yes, in this case, it wasn't necessary. You can just make the post to the metadata service, and away you go on there. Works just fine. But if you're running into this, another case that you might want is to be able to redirect somewhere with the post spotting stuff intact. And at least for me, the redirections that I'm most familiar with are your like 301 and 302 largely. Little bit with 30, or the one I want to call out though is a 307 redirect. And that's because a 307 redirect specifically will not tamper with the body or the method of your request, which is just a useful little tidbit to know. If you run into those cases where you can redirect and then, bypass a block list. Using a 307, you can redirect them and still have like an entire post body get redirected to you, for example. Um, so it's just something I want to call out as they brought it up in here. In passing, I just wanted to call out that area as a worthwhile trick to be aware of, even though it wasn't actually applicable in this case.
Yeah, for sure. Good thing to call out there. Yeah, well written post. Talks about the webhook and how they took advantage of it and the various redirection URLs. The bypassing the fix part was probably the most interesting to me because like I've said in the past, it's it seems really easy to make like bad fixes, even if you're Google. So um, again, it's kind of they made the same mistake with the fix that they kind of made with the initial issue, which was just not considering all the ways that um, the redirect could be abused. So
Yeah, and I mean, in this case, they had initially used the beta endpoint, which didn't require any of those security headers, and then not catching both security headers that you could use. I feel like we actually saw somebody else have the same thing where they had another Google application that was getting patched. They had like 2 or 3 bypass, and one of them I think was similar to this. So maybe that's something to keep in mind if you're reporting something to Google is, you know, try for some of those alternates because it seems like at least some of their people aren't fixing them. And also out of chat, is that payout after GNS fees? No. So the reward was being Google, they like to do the leet reward. So the reward for the initial vulnerability was $3,133.07 or 70 cents. Um, and then because they did the bypass, they got the same thing again, leading to the 6,267 and 40 cent bounty. So weird number because it's leet times 2.
Google loves their meme payouts. It's like their favorite thing.
I mean, you're getting a little bit extra out of them, so can't really complain there.
Yeah, I shouldn't complain. Yeah.
One of my first salary negotiations, I actually negotiated around the value of it, just on the looks of it, not on getting too much more money. It wasn't around leet. I had negotiated for a nice round binary number.
Oh wow. Okay. I'm a little disappointed it wasn't late, but fair enough.
Yeah, well, I mean, I guess I could have gone that route too.
But then you would have been stealing from Google, like stealing Google's idea. So
Well, I mean, leet is not Google's idea.
no, but using it for like payouts and stuff is. At least I haven't seen anybody else really using it. But yeah, we'll get into our last topic here, which is a post from Portswigger on the ad blocker uBlock origin and a CSS injection and their filter rules that could allow universal exfil over CSS to on any site that AdBlock origin or sorry uBlock origin was enabled on. I believe we touched this
Well,
briefly in a
I
previous
don't.
episode.
Sorry, your summary I don't think is quite accurate. So this is specifically they're assuming that the attackers have the ability to install malicious rules, and then they could compromise the sites you're visiting, assuming you've installed their rules. That's a big ask on it. It's not just any website. If you've got uBlock, you're compromised. I think there might have been when we talked about it last episode, because I mentioned this dropped. I hadn't yet fully read it. I might have said something like that, in which case I was mistaken. Sorry to anybody who thought it was going to be that cool of a attack here. I mean, there's still some interesting things here, but it wasn't
Yeah.
quite that.
So I was kind of operating off of what we were talking about. Yeah, when we were talking about what Tavis Ormandy posted a little while ago. So yeah, that was a faulty assumption on my part. So my bad. But yeah, like I said, I believe we touched on this on a previous episode. Here, Gareth Hayes went into technical detail on the vulnerability and some bypasses they had for the initial fixes, as well as how the exfiltration through CSS was actually done. Um, Unfortunately, the post didn't seem to be that great at actually explaining the injection vectors or how exactly they were taken advantage of. So Z ended up digging into these to get a better understanding of them. So Z, I'll let you get into this one.
Yeah, and I had to dig for this one. So I will also say they cover a lot of writing a CSS based keylogger, stealing script content, and a lot of tricks like that. That part of the post was good. It says first, like third of the post that covers on taking uBlock origin rules and injecting arbitrary CSS with them. So usually you're using this, either it's going to match like a selector to hide it, for an example, like blocking ads, you give it the selector, it'll hide everything that matches it. The other option there are these cosmetic rules that he gets into, which are used to like change how a website looks. So you can include some CSS there. What you can't do is anything that would create a URL request. So you can't like exfil anything through it. In which case he ends up bypassing that. So starting off with Tavis or Mandy's issue, which is this first one. Unfortunately, this is one that I think you're going to want to have to watch us on YouTube rather than just listen for. But the basic idea here is that Ormandy's attack uses two rules. The first rule just creates this little style pseudo attribute, I think that would be. I don't know all the CSS terms. And just puts a comment in there, starts a comment, and then the second rule ends the comment, and then at that point you're kind of inside, plus a semicolon, you're kind of inside the global CSS scope. So you can just start injecting whatever CSS you want, or at least you can break back out to get to the whole global scope. You're, wherever that one happened to be injected or where that comment started. So I mean, just create a few of comments there. Kind of a oldish style of attack. What they did to block this, though, was specifically the fact that Ormandy's attack here injected into that style pseudo attribute. So they just block, like, inside of style, make sure there's no comments. You can't do that anymore. So the bypass was to create this rule, and it's just part of the selector itself now. Just putting the /star in the selector, and then ending it in a second rule. So again, using two rules, using the comment, just a new place to inject the comment. And then they started looking at some other takes here. And this is where I kind of had to start digging at least a little bit more to understand what was going on. You'll notice in this past one, it's injecting, the injection is a background color red. In something next ones, like he's using this example where this is not red because he's injecting color red. So you saw that. So when I read this one, I was looking, okay, this is the injection here, which is end comment, font family, background color red. And I was very confused by this. Turns out where it actually is up here at the start. You have the start comment. So the first rule starts with a /star to start your comment. Second rule starts with a /star/, which gives you the end comment in there. And so kind of the surprising thing here on why that even worked is how uBlock origin would validate the selectors or figure out what the selector was. Is it would take this first part before you get to the curly braces or actually defining any CSS attributes. And it would just take that, toss it into document query selector, and from there just try and figure out, is this a selector or not? Like, does it return anything? I actually do have the patch, which I did find looking at the actual patches to kind of help at least a little bit, but it literally, like, the patch on this one ended up just being, does this include a /star in it? Does the selector, but what it was doing there before the patch was it just passed it into the selector. And I'll be honest, reading this document, it just goes and mentions like this works because document selector tolerates malformed. And I had no idea why document selector mattered here at all. But yeah, I mean, I thought that was kind of an interesting one. Little bit misleading as the reader. I was expecting it to be over here with the last one rather than up at the start. I think had I just been paying more attention and noticed this closed comment, probably would have been able to spend less time on it. That's the most interesting one that he came across here, was really abusing, or he actually did some fuzzing against CSS. and basically figured out what characters could be used as like a selector, what characters would consume the semicolon so that basically it wouldn't cause a new rule to be created and you can split things across. A weird thing, but what he came up with was this single line. So this one doesn't inject a comment anymore. Instead, this one ends up basically looking at, or basically creating this really weird selector. I guess the selector technically starts with the star. Where he gets the background URL basically injected in there, and uBlock goes through this and thinks this is a selector, this is okay, and adds it in. Actually, I do want to pull up the commit for this one too. I just should have had this a little bit more ready.
It is unfortunate they didn't go into more detail on some of these, because just like reading through it, I remember when I was reading through it and I was like, I don't really know what the relevance is of these different selectors. So yeah, it's good you're bringing up
Yeah,
the
well,
patches here.
he doesn't quite go into the relevant of all the selectors, but what uBlock's doing here, with some of these rules, is, or what it would do is, it would to test the rules, it would create a style sheet and it would try and insert the rule where it would match the selector and just give it a color red. It would just insert that rule, and then its check would just be, does this work, or is the rule's length not equal, or sorry, that's the patch. The old version was just, did it inject a rule? So it would just check, is the length equal to 0? If the length is equal to 0, this was an invalid rule, so that was not a valid selector. Whereas what they're doing now to patch it is, actually, before I do that, back on the actual thing here. So what's happening in this one is basically smuggling in that background URL, that arbitrary CSS. He's smuggling that inside of the selector itself, making it think that this is the selector and not more CSS. But when that actually gets injected into a sheet, it's going to inject that as a new CSS rule along with the thing that thinks is the actual CSS rule, which is why this patch was insufficient. Or which is why the original code wasn't sufficient, because it was checking for the failure case instead of the expected success case. So the expected success is you add this, you get one new rule. And that's what they actually check, is they, instead of what the patch ended up being, and this is just kind of a good way to patch issues, is what, instead of just trying to match your failure, what does success look like? And had they been matching that from the beginning of what does the success case look like, and everything else is invalid, they would have been able to avoid this. That said, I don't really expect everybody to be thinking about that by any means. It's just the perspective, I think, that I thought was interesting with this one is just how simple the issue was because they were checking the wrong outcome. So yeah, it would inject more than one rule at that time. That one rule would actually create at least two. Meaning, is it not equal to, or is it equal to 0, return false? Obviously, it would be equal to 2. The patch, make sure it's equal to 1, or rather, if it's not equal to 1, return false. It's no good anymore. So that seems like a sufficient patch for any sort of these smuggling issues of that sort, at least in this area, which I thought was really interesting. I wish they would have explained it better in here. Rest of the document, they talk about using image set in Firefox, which is just another way to call URLs that wasn't being patched or wasn't being blocked. In Chrome, in other browsers, that also exists as WebKit image set, but can't be abused because you need a call with a URL also. It's just Firefox that had that kind of bypass. And that goes into plenty of the actual exfiltrate CSS, and that part is, I think, explained a lot more clearly. So I mean, that part's good. And I would actually say that this is a good reference if you're in the case of having a CSS injection on how do you exploit, because in addition to having some good write-ups on some takes like a CSS keylogger, like being able to steal script content, or at least first however many lines, characters of it, you're getting that, but you're also getting links to a lot of researchers that he built his work off of. And so there's just plenty of resource in here. There's like a trove of CSS injection resources and links within this that I think are really useful if you're actually in that scenario. And that's where I think the bulk of this post goes on. It does also deal with this JavaScript URL injection. I didn't find that one to be all that interesting. Basically, one of the allowed domains was github.com, so you could end up causing the add filter dialog to open from a GitHub page. Which, fair enough. I mean, GitHub does have untrusted data, but you could trigger the adding the filter right from any GitHub repo. So like it's a fair issue, but I found the first part, the actual injections with CSS, to be the most interesting part of this. And these all, once again, do rely on the attacker having installed some malicious rules, or either through vulnerability, like what he was searching for, or just compromising a existing list, or you actually installing them. That said, that I think is a relevant attack surface here, because how many of us actually validate all of the rules our ad blocker uses? And I'm assuming you're using an ad blocker. If you're not, you probably should.
Yeah, I mean, Post is a bit of a long read. They go into like a lot of details here. Like you kind of mentioned earlier, I think the more clear part, at least from the bit that I was able to read, was in the when they get into like the CXS or sorry CSS exfil. Like I was mentioning, mixing XSS and CSS there, but yeah, but like the first half of it was like a bit of a struggle for me. So um, I'm glad you were able to dig up more details and go through the commits and like and whatnot.
Yeah, and all those links and stuff will be on our Vuln page for this one too. I wrote up the summary for it.
Yeah. All right, but yeah. With that said, that's our last topic. Z, unless you have anything to add on to that, we'll go ahead and wrap up the show.
Oh, we're good.
All right. So thank you to everyone who tuned in. You can catch the VOD on Twitch immediately or on other platforms like YouTube tomorrow. We also have previous podcasts up on Spotify, Apple Podcasts, and more links on Anchor. If you want to join our Discord and follow us on Twitter, links for those are down below or in the chat. We'll be back tomorrow for our last podcast, which is the binary podcast episode at 7 p.m. Eastern, 4 p.m. Pacific.
It's less
And
for the
that will
year.
be last for our for the year, not forever. So yeah, that will be our last show until January 2022, and yeah, we'll hopefully see you all tomorrow.